All right, hey organic chemistry. So instead of me having to try and keep up with all of you copying notes at different times, I decided to make a video for these next couple of pages of notes. So we're going to do a little bit of recalling and then talking about what we last talked about in class about bond line drawings and hydrocarbons. So remember, if we have bond line drawings, each corner and end point is a carbon. So if you were to put a circle, a shaded circle on each corner and end point for the structure that we're about to talk about, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 carbons. All right, we got 10 carbons. Carbon needs 4 bonds in total. If there were less than 4 bonds shown drawn to the carbon, the rest are hydrogen. So let's do each one, right? So I'll do these ones on the end, because these ones on the end are easier to see. This only has 1 bond shown drawn to it. That means it needs 3 hydrogens. And I'm just going to draw a line for hydrogen. So there's 3, 6, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So all of those carbons on the end need 3 hydrogens. Then let's look at this carbon. This carbon has 1, 2, 3 bonds shown drawn to it. It needs 1 hydrogen. This carbon has 1, 2, 3, so it needs another hydrogen. This carbon shows 2 bonds drawn to it, so this needs 2 hydrogens. This carbon has 1, 2, 3, 4 bonds shown to it, so no hydrogens. Altogether, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. 22 hydrogens. Which means its formula would be C10H22. But as I mentioned in class, there's a much easier way to do this. So instead of having to count carbons and hydrogens like this, you could use this homologous series of hydrocarbons. To figure out the number of carbons and hydrogens for a given organic compound, we can use the following table. If it's all alkanes, meaning all single bonds, we could use the rule CnH2n plus 2. CnH2n plus 2. If there was a double bond in there, it would be CnH2n. If it was a triple bond in there, CnH2n minus 2, where n is the number of carbons. So for this one, we know that n is equal to 10. If I want to do H is going to be equal to 2n plus 2, which is equal to 2 times 10, or 2 times 10, I'm doing it 3 different ways, plus 2. 20 plus 2 is 22, which is what we got. So that is a shortcut into counting carbons and hydrogens. And so I want to make sure that we know how to use this table. And so I'm just going to be copying and pasting the equations and plugging and chugging using CnH2n. So if I want to do alkanes, let's plug in the equation I would use CnH2n plus 2. For an alkene, it would be CnH2n. For an alkyne, CnH2n minus 2. And so let's say my value of n was 8. That means I had 8 carbons. For an alkane, my number of hydrogens would be H2n plus 2. So 2 times 8 plus 2. 8 times 2 is 16, plus 2 is 18. So the formula would be C8H18. For an alkene, I would use 2n. So 2 times 8, which is 16, so C8H16. And then for an alkyne, I would use 2n minus 2. 2 times 8 minus 2. 16 minus 2 is 14. C8H14. Okay, so if you know how to plug and chug into these equations using this table, you could easily figure out formulas given information. And then we could name these formulas that we made up here. So alkanes end in ane, alkenes end in ene, alkynes end in ine. And if there was a ring, I would use cyclo. And for the number of carbons that we have in the chain, we use these prefixes. So if there's only 1 carbon, I would say, and it was an alkane, I would say methane. If there was 7 carbons and it was an alkene, I would say heptene, and putting that together. So let's write the formulas that we came up from over here in the bottom table here. So chemical formula C8H18, C8H16, H14. Number of carbons for all of them are 8. And for 8, I'm going to use oct for my prefix. So I'm going to use oct somewhere. And the type of hydrocarbon, I put it up here, alkane, alkene, and alkyne. And if I want to name this, if I want to name 8 carbons that are an alkane using oct, it would be octane. 8 carbons that is an alkene that has a double bond, octene. 8 carbons with a triple bond, octyne. Don't forget that rings get the cyclo prefix. So the following, I have 1, 2, 3, 4, 5. There's 5 carbons. They're all single bonds. So 5 carbons up here in the table gets pent. All single bonds ending in ane. And then if it's a ring means that they all close together as opposed to 1, 2, 3, 4, 5. This is not a ring. They don't close. This would be pentane. But when these 2 carbons connect on the end, I get cyclopentane. And if I wanted to do and show you cyclooctane, it looks like a stop sign. 1, 2, 3, 4, 5, 6, 7, 8. This would be cyclooctane. 8 carbons, all single bonds in a ring connected cyclooctane. Okay? All right, so going back to this, if I wanted to name this parent chain, if I'm given this a hydrocarbon, before we said it was C10H22, 10 would be decane. 10 carbons, all single bonds, would be decane, but that's only if it was like this. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This would be decane. The longest chain would be 10. Remember from our notes from our previous class, I need to find the longest chain. So if I wanted to find the longest chain, let me see. 1, 2, 3. That's not enough. 1, 2, 3, 4. I could definitely go longer. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. It doesn't matter. No matter what I get my longest chain right here. Okay, my longest chain here, which is not like up here, this is a 10 carbon chain. That would be decane, but there are not 10 carbons in a chain. The longest chain I have, 6 carbons. This would be named hexane as the parent name. So combining what we've talked about with using prefixes and counting carbons and hydrogens, what you have to do is, given certain information, either if I tell you that there are 8 carbons and it's an alkyne, I could tell you what the name is. Or if you find the longest chain, tell me how many carbons are in that chain. If there's a single, double, or triple bond, I could figure out whether or not it'll be named alkane, alkene, or alkyne. So what I want you to do after you watch this video is start doing some of the practice for practice 1, 2, and 3. For practice 1, and I'll do some of them, if I said something like alkene is 7 carbons, give the type of hydrocarbon and the number of carbons, given the type of hydrocarbon, number of hydrocarbon, determine the chemical formula. Right? So if I was an alkene with 7 carbons, alkene, I'm using CnH2n. So its formula would be C7, 2 times 7, H14. Okay? Something like alkene with 20 carbons. Again, CnH2n, because it's an alkene. C20, H40 would be the formula. 2 times 20 is 40. For these problems, you could count the carbons and figure out the hydrogens, or you could just count carbons and hydrogens all together. For practice 2, you're going to be either giving me the formula, giving me the number of carbons, or naming the compound. So for example, if I were to jump to something like this, Number of carbons, C9H20, there are 9. The name it would get would be nonane. If I'm going to jump to ynes down here, these are my ynes, right? C10H18, there are 10 carbons. That would be called decyne. Nonine would be the one with 9 carbons, right? And so if you look at these tables, this is for my anes, my enes, and for my ynes. And then finally, on the last page, I want you to identify the longest chain. So for example, and then give me the name. So for example, for something like this is 1, 2, 3. No matter what I do, I get 4. 4 is my longest chain. If I look at my notes for all single bonds and 4 carbons, that's going to get butane. So the name of this 4 carbons gets bute, and it's all single bonds, ane. Putting that together, I get butane. Something like number 9 here, if I find my longest chain, 1, 2, 3, 4, 5, 6, nope. 1, 2, 3, 4, 5, 6, 7, 8. Oh yeah, that's got to be the longest one. I have 8 carbons, which is going to be oct. And then I have a double bond, which is going to give me the ending ene. So this is going to have the parent name of octene. We're going to name these compounds completely. I'm just looking for the parent chain. We're ignoring the things that are attached to the chain for right now. But this is going to be my parent chain, as we mentioned in class with notes. My longest chain is, I have to figure out how many carbons, and I have to use the prefixes to figure out its name. All right, so use this video to help you with practices 1, 2, and 3, and to get the notes. If you have any questions or concerns, you could ask me during class.